Okay, whoops, I hit the wrong button right away. What do you know? Okay, the section title is what? Section number is 6.9. This is a new textbook from last year. They moved this section from where it was to here. I don't like it. I think it's dumb where they moved it to. So we're going to jump from 6.4 to 6.9 and then go backwards, which is going to be a little strange, but it makes sense in my head, okay, as far as why we're doing it the way we're doing it, because you kind of need this section to do the next one, and why they think you don't, and they do it the way they do in the new book is beyond me. Okay, so we're going to go do this one, and then we'll go backwards, okay? But 6.9, solving logarithmic equations. This is actually fairly simple. Alright, it's not terrible. Okay, so we kind of were starting to work with stuff that looks like this the other day. Whenever we switched, right, when we did logarithmic to exponential switches. Now the difference here is instead of us setting this equal to a variable and simplifying it down from there, now we have the variable over here. Everybody see that? So instead of setting this equal to a variable, we have a variable here and it's already telling us what it equals. So we want to figure out that number. Okay, we want to solve for x. And the easiest way to do that is to do your logarithmic to exponential switch, which means 36 becomes the base. The exponent goes to 3/2. And it's equal to x. Alright, so 36 goes to become the base, 3/2 moves to the exponent, and it equals x. Is everybody cool with that switch? Okay, I've seen that before, yes? Good, you get that. After you do that, I do these problems like this. I see 36 and I think 6 squared. Okay? So I see 36 and I make it 6 squared. Still to the 3/2 power equals x. Okay? Now my question for you, these powers, what do you do with? What do you do with these powers? You multiply. Okay? Multiply 2 and 3/2. So what is 2 times 3/2? 6 over 2, which reduces to 3. So that exponent becomes 6 cubed. And 6 cubed is no, it's not. Or is it? It's 216, right? Yeah. Brain fart. Okay. So that's the one type of problem here where you have the logarithm on one side like this. You're given the base number, you have a variable here, and it equals some number here. Okay, you switch to exponential form with it, you simplify it down like we've been doing this chapter, and then you get your final number. Alrighty? Questions on that? Everybody okay? Okay, so a couple more like that. We have log base 9 of x equals 3/2. So same way. Switch it, so 9 becomes the base, 3/2 goes to your exponent, equals x. 9 is 3 squared. To the 3/2. 2 times 3/2 is 3. So 3 to the third equals x. 3 cubed is 27. Alright, this last one over here, 16. Log base 16 of x equals 5 halves. 16 to 5 halves equals x. 16 is 4 squared to the 5 halves equals x, which means 4. 2 times 5 halves is what? Ten over 2, which is 5. 5 to the x. And then 4 to the 5th. Help me out. 10, 24. No. Let's say you have log base, I don't know. Haley, pick a number. 15. Log base 15. Let's go with x plus 7 equals 3. Let's not. Let's make that equals 2. So log base 15 of x plus 7 equals 2. Okay. What's in parentheses? X plus 7, right? So that whole quantity, that x plus 7, is what you're taking the log of now. Okay, not just the x, like it was the last 3, but now the x plus 7. So your first step is still the same. You're still going to switch. You're going to switch forms. But when you switch forms, 15 becomes the base. The exponent on 15 becomes what? 2. And then the whole entire right side becomes what? X plus 7. The whole thing goes there with it, okay? So it becomes x plus 7 over there. That whole quantity that you're taking the log of, since it's all in parentheses, this whole thing shifts to the, shifts to the right. And you set it up like this. Alrighty? And then you solve it. So it's 15 squared. 225. This big number is Haley's fault, just so you know. Alright? 225 equals x plus 7. Last thing, subtract 7. So 225 minus 7 gives you 218 equals x. Okay. Make sense? So that's one type of problem today where you have the logs on one side of the equation. Alright, logs are on one side of the equation. Good? Now, we already know how to handle that, or we knew how to handle that when we had logs on one side. You just do an exponential switch and then you move along. Now, we're going to have a second type, and we need a new property, okay? It's called the property of equality for logarithmic functions. Okay, skip the symbols, go to the example. If log base 5 of x equals log base 5 of 8, then x equals 8. If log base 5 of x equals log base 5 of 8, then x equals 8. So put that in your words. If this and this are the same, then those are equal. So if this log has this base is equal to this log with this base, you can basically do what with the logs? Cancel them, right? Because if we have log base 5 of x equals log base 5 of 8, then x equals 8. The only thing that changed from here to here was you canceled out the logs, right? Leaving you with x equals an 8. So that's the nice part. So if you have logs on both sides of your equation, like we do here, then you can just take them, drop your log, and set the quantities equal to one another. All right? Does that make sense to everybody? Okay, now before we move on, I don't want to say I've been lying to you guys. I just haven't been telling you the whole truth. And there's a difference. Okay? So I haven't lied to you. I just haven't told you everything. Everybody got their calculators? I want you to hit this button. Ready? I want you to do log. See the log next to your calculator, next to your 7? Okay, we'll just use it and we'll talk about it later, why the numbers pop up the way they're going to pop up, okay? But I want you to do log of 100. So log 100 equals, what do you get? 2. Right, do log of 1,000. What do you get? 3. Okay. Do log of 1. 0. Do log of 0. Error. What kind of error? Does it say? Domain error. Everybody see that? All right. Now, we've heard that word, right? We've heard domain before. Domain is your x values. And it just told you you have a domain error. That means that 0 is not able to be taken the log of. Did that make sense? You can't take the log of 0 because it's not in the domain of your logarithms. It's not one of the x's that work. Okay? So hit quit and try again. Let's try log of negative 10. Or let's do log of negative 100, right? Log of 100 was 2. Log of negative 100 should be negative 2, right? Makes sense? What did it tell you? Negative 2? Non-real answer. What? Which also basically means that negatives aren't in the domain either. So you can only take the log of what type of numbers? Positive. Okay? You can only take the logs of positive numbers. Keep that in mind here. All right? So let's move on. So solve. Log base 4 of x plus 3 equals log base 4 of 2x plus 1. You got to check two things here. Do I have logs on both sides of my equation? Yes. Do those logs have the same base? Yes. Will they always have the same base? Actually, yes. All right. For you guys' purposes, they'll always have the same base. So you never have to worry about that. You just got to make sure whether you have one on one side or logs on both sides. That's what you got to worry about, okay? So now that we determined that we have logs of the same bases to both sides, these logs can cancel out, and you can work with just the x plus 3 and just the 2x plus 1. So x plus 3 equals 2x plus 1, and that's it. And all you got to do now is solve that equation. So minus x minus 1, x equals 2. Okay? X equals 2. Now, what did I not do yet? I didn't do something that I always do with my answers, and that's what? I didn't circle it yet. Okay, I didn't circle it yet. Because now that we have an answer, we have to go back up here and plug it in. Okay? We got to plug it in this x and this x. And we need to make sure that the number that results out of these is positive. We need to make sure it's positive, okay? If it's positive, it's a good thing. If it's not positive, which means negative or 0, that's not good. All right? So plug it in here. What's 2 plus 3? 5. So we have 5 on this quantity. Over here, what's 2 times 2? 4. What's 4 plus 1? 5. So we have log base 4 of 5 equals log base 4 of 5. Is 2 a good answer? Yeah. Okay. Questions on that one? Very good. Let's try again. So log base 5 of 2x plus 1 equals log base 5 of x plus 4. Do you have logs on both sides? Yes. Are they of the same base? Yes. So cancel them out. So 2x plus 1 equals x plus 4. Subtract x. Subtract 1. X equals 3. Take 3 to the top. Plug it in. 2 times 3 gives you 6. 6 plus 1 is 7. Plug 3 in here. 3 plus 4. 7. 3 looks good too. Alright, so we got log base 2 of x squared minus 4 equals log base 2 of 3x. Alright. Do you have logs on both sides? Same base? So you can take the quantities and set them equal. So x squared minus 4 equals 3x. Alrighty. What type of equation is this? Starts with a Q. Yeah, everybody's like, what's that big Q word we used to talk about? Oh, I can't remember. Almost. Savannah? What'd you just say? No? Alright. Alright, fine. I know that's a lie. QU. I messed that up. I should have said I'll give you the second letter. Yeah. And then say U. I can't get them all. QUA. D. Almost. So close. Say again. Quadrant? No. There it is. Quadratic, right? The quadratic equation. Alright, and whenever you solve a quadratic equation, it has to equal what? Starts with a Z. Has to equal 0. Good. So we got to subtract the 3x over. Alright, so minus 3x minus 3x. So x squared minus 3x minus 4 equals 0. Anybody remember how you solve quadratic equations? It's everybody's favorite 6-letter F word. Factor! Good. You got to factor. So we factored this one. We need to multiply number -4, add number of -3. So what two numbers in the world multiply to -4 to add to -3? negative 4, positive 1, right? We split them separately, make them each one equal 0, so x minus 4 equals 0, x plus 1 equals 0. This one we add 4, so x equals 4. This one we subtract 1, x equals negative 1. All right? Everybody good? Okay, still got to check these, so don't forget about that. So check them individually, right? 4 goes in for both x's one time. Negative 1 goes in for both x's one time. So let's plug in 4 first. So what's 4 squared? 16. What's 16 minus 4? 12. So when we plug in 4 on the first one, we get 12. What about over here? What's 3 times 4? 12. So both sides is log base 2 of 12, so we're good there, right? So 4 can be circled. All right? Let's check negative 1 next. What's negative 1 times negative 1? 1. What's 1 minus 4? Negative 3. Okay, we plug negative 1 in on this side. What's 3 times negative 1? Negative 3. Are we good? No. You're not good. Not good. They're equal though, right? Log base 2 of negative 3 equals log base 2 of negative 3. Both sides of the equation are equal. We're okay, Mormon. You're lying to us, right? No. Because you're trying to take the log of a negative number. And that's not good. You can't do log base 2 of negative 3. So even though when you plug these in, it gives you the same thing, both sides of an equation, which typically gives you great stuff, since that thing is negative, since that thing is not positive, this number, that negative 1, doesn't get circled. Put an X through it. And put an X. Don't give it the death scribble, right? Don't do this. I need to be able to see what's there. Just put a little X through it. Okay? That's why you have to check these, because just because they give you the same thing on both sides doesn't mean they're good answers, because if that thing is negative or if it's 0, then you got to throw this one out. Okay? Does that make sense? Also, don't be confused with this being the negative and this being negative. All right? It's not just because this is negative and this is negative. They don't correlate. These answers down here could be positive, and then they give you negative up here. Okay? Or they could be negative down here and give you positive up here. There's some weird stuff that could go on. It's what's up here, not down here. Okay? So make sure you go plug back in and check at the top before you cross it out at the bottom. Alright? There's your next one. Don't be scared of the bases when there are logs on both sides. Okay? Now, if it was a log on one side, then your base matters. But here with logs on both sides, base is irrelevant. Alright? So x squared minus 15 equals 2x. What type of equation is it? Quadratic, good. So it said equal to 0, so x squared minus 2x minus 15 equals 0. Multiply of negative 15. Add number of negative 2. Which two numbers get that done? Negative 5 and positive 3. So x minus 5 equals 0, which means x equals 5. X plus 3 equals 0, which means x equals negative 3. Check these out. What's 5 squared? 25. 25 minus 15? 10. 2 times 5? 10. 5 works. Okay? Now, you can kind of shortcut this, right? You don't have to check this one because watch what happens here. Negative 3. What's 2 times negative 3? Negative 6. So on the right-hand side, we have log base 300 of negative 6. Is that good? No. Right there, that's enough to cross that one out. It doesn't have to be both logs. It just has to be one. Okay? Okay, so if 1 gives you a negative, you cross it out. Okay? One more. Ready? Last one. Let's see who's paying attention. There you go. Alrighty. Logs on both sides, they're the same bases, same song and dance. Yeah, okay, cool. So x squared minus 7 equals x plus 5. Make this guy equal 0, so subtract x, subtract 5. So x squared minus x minus 12 equals 0. How does it factor? X minus 4, x plus 3 equals 0. So x equals 4, x equals negative 3. Alright, so now let's start plugging these guys in. So what's 4 squared? 16 minus 7? 9. What's 4 plus 5? 9. So 9, 9. So x equals 4. Good answer. Good answer. Good answer. Let's try negative 3 now. What's negative 3 squared? 9. What's 9 minus 7? 2. Oops, that was still the eraser. 2. What's negative 3 plus 5? 2. Log base 12 of 2 equals log base 12 of 2. Is negative 3 good? Yes, good answer. Good answer. They both work. It's not when this is negative, it's when up here is negative. But you got to cross this one out. Okay? Be aware of that. Questions from the masses? All 7 of you. Pretty good? There's your homework. All right. Page 439, numbers 9 through 19, skipping 13. Lesson check tomorrow.